So we're back in the lab today, and today we are going to be looking at the purity of this magnesium ribbon. Now, if you look at it, it's a little corroded on the outside. Magnesium reacts with oxygen, so this is probably not 100% pure magnesium. And we're going to figure that out by reacting it today with hydrochloric acid. So how we're going to do this, we're going to use the ideal gas law. We're going to react a small piece of this magnesium, a real small sample, with excess hydrochloric acid in this eudiometer. Now, a eudiometer is a closed glass tube that if we invert it, we fill it with water, we invert it, we have basically a water column. And once this reaction starts to produce hydrogen, it will fill up this eudiometer, and we can use these graduations to measure the volume of the gas that we produced. Now, because we're doing this over water, the gas that we're collecting in here also has water vapor, right? So we have to take into account the pressure of that water vapor and remove it from this volume of gas. And then we can use the pressure of just the hydrogen to use the ideal gas law, PV equals nRT, to determine how many moles of hydrogen were produced. If we know how many moles of hydrogen were produced, we can figure out how many moles of magnesium actually reacted, and then we can determine, knowing how many grams of magnesium reacted, what the purity of this sample is. It should be 100% or less. So we're going to go ahead, I'll show you the reactants first, and then we'll go ahead and set it up and let the reaction go. So before we get started, let's take a quick look at our reactants. That little piece of magnesium that I had showed you earlier, I've curled it around a stirring rod and tied it to a stopper with a string so we can hold it to the bottom of the eudiometer. We don't want it floating up to the top. In that little graduated cylinder, we have about 5 milliliters of 6 molar hydrochloric acid. Now we're going to pour that acid into the eudiometer. You'll see this here shortly. Fill up the eudiometer with water and put the stopper in with the magnesium and invert it so that it begins the reaction. So as we get started, first thing we're going to do is take our 5 milliliters of acid and pour them carefully into the eudiometer. And then we're going to go ahead and fill the eudiometer with distilled water up to the top. Now, the acid's a little more dense, so the acid should stay towards the bottom. We're going to pour it in kind of nice and slowly and carefully so that it doesn't stir up the acid. So we're just going to fill up our eudiometer. Okay, right to the brim. We're going to go ahead and put our magnesium inside the solution and put the stopper in. We're going to spill a little bit of water. But we basically introduced no gas into this. We're going to invert it and put it into a beaker of water. And you'll see that the acid, if you could look carefully, I'll try to zoom in, the acid is kind of working its way down. It will reach the magnesium at the bottom and begin to react with the magnesium. So it's going to take a little while for that denser acid to work its way down. Once it does, it will begin to react. And if we zoom in on the top of the eudiometer, we can see that the hydrogen and the water vapor are starting to fill up the top of the eudiometer. we will be able to look at the graduations on the eudiometer to measure the volume of gas that's being produced. After about 5 minutes, you can see that we're roughly at about 21 milliliters of gas formed, and it's still going, so we'll let that run out till the reaction is complete. We can see now that the reaction is nearing completion, and there's very little hydrogen being formed, although there's still some. We will let it run completely and look at the volume after the reaction has stopped. So now I've transferred the eudiometer with the hydrogen to a graduated cylinder that's full of water, and the reason I'm going to do this is because I'm going to try to go ahead and get the water level, or the gas level, down to the water level of the graduated cylinder. And the reason I want to do that is because I want to equalize the pressure inside the eudiometer to the pressure outside, because I can measure or look up the temperature, or the pressure of the air on the outside. So if I get these water levels equal, that means the pressure inside is equal to the pressure that I've looked up for today for this room. So the other thing I'm going to do is take the temperature of this water, because I'm going to use that to find the partial pressure, the partial pressure of the water. So I'm just going to go ahead and let that settle. I will put the data in the data table. So just to summarize what we've done, we went ahead and reacted a sample of magnesium in this eudiometer with excess hydrochloric acid. We produced a certain amount of hydrogen gas, which we then measured the volume of. Now, keeping in mind there's also some water vapor in this mixture of gases here. Once the reaction was complete, we set the pressure inside the eudiometer equal to the pressure in the room, which we looked up to see the pressure in the room. We got the temperature of the water so that we could figure out the temperature of the water vapor in the eudiometer. Okay, so we're going to put all this data together. It will be presented in a data table. We're going to do this experiment 2 more times to try to get an average. And again, our goal here is to figure out how many moles of hydrogen were produced once we remove the water vapor. That will allow us to figure out how many moles of magnesium were reacted, and that will allow us to figure out what percentage of that sample was actually magnesium as opposed to any kind of impurities.